Hi guys, it's Mrs. Seitz. Today what you're going to be doing is you're going to be proving statements about angles. So by the end of today's lesson, you should be able to answer the question of how do you use angle congruence properties. So we've seen some of these properties before, except now I'm going to show you how they would apply to some angle properties. So we've seen the reflexive property. So if, for example, you've had angle A, it would be congruent to angle A. In the symmetric property, when you can see things being kind of flipped or like kind of like a mirror around, right? If angle A is congruent to angle B, then we can say that angle B would be then congruent to angle A. And the transitive property also works here in congruence with that middleman. So if angle A is congruent to angle B and angle B is congruent to angle C, then if we cut out that middleman, we can say go straight from angle A and go to angle C. So angle A would be congruent to angle C. We're also going to be defining some things about right angles. So we will say all right angles are congruent. So if we have angle A being congruent to angle B, you can see that if we have these two angles, then by their measures, you can also see that they're also congruent. So we can always use that whenever we use some proof. All right, if we take a look, guys, at our first example, okay, we're going to be given some things we know about some angles, and then we are going to have to make a statement about these angles. All right, so we don't necessarily have a picture, but we can always draw a picture for some of these problems too. All right, so let's see what we know. It says angle 1 and angle 2 are supplements, which means, remember, they add up to 180 degrees. Angle 3 and angle 4 are also supplements, which means they add up to 180 degrees. We're trying to prove right now that angle 1 is congruent to angle 4, and we're going to prove that angle 2 would then be congruent to angle 3. So let's see, we can write some things down. We may or may not need a picture. We'll see what we can do here, okay? So let's write some things down that we know. Always write down our givens first. All right, so let's write down angle 1 and angle 2 are supplements. And we can also write down angle 3 and angle 4 are supplements. And they're also telling us in the given that angle 1 is congruent to angle 4. And our reason is that it is given. Okay, so let's think about some things here that might help us. All right, so let's go off of what we know about supplementary angles. All right, so I know that if I added up the measure of angle 1 and I added up the measure of angle 2, it would have to equal 180 degrees. Likewise, if I took the measure of angle 3 and the measure of angle 4, it would also have to equal 180 degrees. And I know that based on what I've learned in the past about supplementary angles. So I'm just going to say definition of supplementary angles. Okay, so based on that fact, I can say that if I add up their measures, it equals 180 degrees. All right, now I'm going to take that little fact in the given about angle 1 being congruent to angle 4. And since I'm kind of going and talking about some things with equality, I should probably kind of convert that into something about equality too. So do you remember from yesterday or from yesterday's lesson, whenever we were talking about converting things between congruence and equality? If I want to say that angle 1 is equal to, so we say the measure of angle 1 is equal to the measure of angle 4, to get me between congruence and equality, that's that definition of congruence, and that works here with angles as well. All right, I need to use that information to help me to get to some things that I want. So let's say, for example, that maybe I wanted to use that statement here about the measure of angle 1 plus the measure of angle 2 equaling 180 degrees. And the fact that I know that the measure of angle 1 equals the measure of angle 4. I can kind of put those two things together, and I can actually substitute in the measure of angle 4 in for the angle of 1. The reason why I might want to do that is because eventually I might start wanting to put some things around so that I can eventually get some kind of statement saying that angle 2 and angle 3 are equal to one another. So I kind of want to start playing around with some of the other angle relationships. I'm going to show you guys how to do this and just kind of watch how it plays out. So look what I do here. If I plug in that measurement of angle 4 here, plus the measurement of angle 2, and say that's equal to 180. Okay, that was with the substitution property, and that's of equality. Okay, so I'm kind of heading in the direction that I want to get like angle 4 out of here because I want angle 2 and angle 3 left over. Okay, so because that's what I'm kind of trying to prove, right? I want angle 2 and angle 3 left over. So I have these two statements right here in step 2. So I'm betting if I say something about the measure of angle 4 plus the measure of angle 2, I know they're equal to 180. And I know that the measure of angle 3 plus the measure of angle 4, that's equal to 180. I kind of have that middleman, right? So like the middleman would be the 180. I can kind of take out that middleman of 180, and I can set this up by saying the measure of angle 4 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4. And that's going to be my transitive property because I'm taking out the middleman of equality. Okay, now, do you see how we're kind of getting closer to what I want? I'm getting the 2 and the 3. You see the 2? You see the 3? I got to get rid of that measure of angle 4. So, you know what I'm going to do? I'm going to subtract it off of both sides. So if I subtract off the measure of angle 4 from both sides, look what I get. I get that the measure of angle 2 equals the measure of angle 3, and that's my subtraction property of equality. All right. Oops, I'm almost there. I just got to get from equality to congruence, and we know how to do that. So to get from equality to congruence, I'm going to say that angle 2 is congruent to angle 3, and that is going to be taking me because of definition of congruent segments or definition of congruence. All right, so kind of was going in between, plugging some things in, but I wanted to eventually get that angle 2 and angle 3 were going to be congruent based on some things that I had learned in the past. So I used that fact that angle 1 and angle 4 were equal to one another so that I can kind of manipulate that to get it out of there so that eventually I'd be left over with 2 and 3. Don't worry, if you're getting a little confused, don't freak out. Eventually, you're going to see that there's some patterns with these kinds of problems after you practice a couple. Let's try another one. Before we get into another proof, I want to show you this congruent supplement theorem. So if two angles are supplementary to the same angle or congruent angles, then they are congruent. So if I have that the measure of angle 1, so you see it's 120 degrees, and the measure of angle 3 are supplementary to the measure of angle 2, then we know automatically that the measure of angle 1 is equal to the measure of angle 3. So if we knew that fact earlier on, we could have actually shortened this proof by a bunch because we knew some of those facts earlier on. All right. But for future reference, now that we know that we have two angles being supplementary to the same exact angle, now we can use this shortcut and we can call it the congruent supplements theorem. All right, here's another one, the congruent complements theorem. If two angles are complementary to the same angle or congruent angles, then they are congruent. So angle 1 and angle 3 are both 50 degrees, right? They are both complementary, which add up to 90 degrees, right, to angle 2. So therefore we can say angle 1 and angle 3 are equal to one another. And again, we're going to use the congruent complements theorem to help us out in the future as well. All right, so let's take a look at our next proof. So let's take a look at that one. And again, all these extra proofs or extra theorems that we're talking about, we'll be adding that to our list that we have been working on of all the possible reasons that you guys could be using in proofs. All right, so we know angle 1 and angle 2 are right angles. We know that angle 1 is congruent to angle 3. We're trying to prove that angle 2 is congruent to angle 3. All right, so let's start off by writing down our given. We know that angle 1 and angle 2 are right angles. And that is given to us. Okay, the other thing we know is that angle 1 is congruent to angle 3. Okay, so we just learned something that if we have right angles, that all right angles are congruent. And we learned that actually at the beginning of today's class. Let's go back. Oops, there it is. If we look at this, if we have any right angles, we can say that by the right angle congruence theorem that all right angles are congruent. Well, when we stated that angle 1 and angle 2 are right angles, then we can say right off the bat that angle 1 is congruent to angle 2. And we're going to say that through the right angle congruence theorem. Okay, we said that because if we have right angles, automatically all right angles are congruent. All right, this proof is actually going to be short and sweet because look at what we're trying to solve. We know we're trying to prove that angle 2 is congruent to angle 3. If I look and see some of the things that I already have, I actually think I already have it because look what I have. I have a middleman that I can come out. So if I can cut out that angle 1, I actually have my statement. Angle 2 is congruent to angle 3, and I cut out my middleman, right? So that would be the transitive property of congruence. Okay, so again, sometimes the proofs are short and sweet. So wrote down my given. I knew that all right angles are going to be congruent to one another through the theorem that we learned earlier. I saw that I had that middleman between the given statement and what I just wrote down about right angles being congruent. Cut out my middleman and got to exactly what I was trying to prove. All right. All right, let's take a look at the next one. So we're given that the measure of angle 3 is 30 degrees, or measure of angle 3, not the measure of angle 30. Sorry about that. The measure of angle 3 is equal to 40 degrees. And let me cross this out. Angle 1 and angle 2 are supplementary. We also know that angle 2 and angle 3 are also supplementary. Oops. So we got to prove somehow that the measure of angle 1 is equal to 40 degrees. Well, since I'm looking at things right here and I'm seeing two things with supplementaries, I'm kind of thinking about that new supplements theorem that we learned today. But before we get into that, let's just go with what we always do and write down our statements that we have that are given to us. So we're going to say that the measure of angle 3 is equal to 40 degrees. We also know angle 1 and angle 2 are supplementary. And we know angle 2 and angle 3 are supplementary. And that's because those are given to us. Okay, so now let's take a look and think about this, okay? In order for us to be able to use some of those things that we've looked at before, we have to use some kind of congruent statement to get there, okay? But I'm going to go back to that congruent supplement theorem just to make sure we have everything. So let's go back. So if we have two angles that are supplementary to the same angle, then we can say that they're congruent. Well, let's see what we have. Let's see. We have angle 1 and angle 2 being supplementary, and angle 2 and angle 3 being supplementary. So I'm kind of thinking that we have that congruent supplements theorem. Let's see what we can do with that. Okay, so since we have that, I think we can kind of say here, see how we have that they're congruent to the same angle? We can say angle 1 is congruent to angle 3, and we're going to say that with our congruent supplements theorem. Okay, now in order for us to get to what we're trying to prove about equality, I was talking about this a little bit earlier, we have to go from congruence to equality. So in order for us to get there, we have to start talking about equality. So in order for us to do that, we're going to take this statement and we're going to convert it to equality. So we're going to say the measure of angle 1 is equal to the measure of angle 3. And we're going to say that's the definition of congruence. So I say we're almost there. So if you look here, we know the measure of angle 1 is equal to the measure of angle 3. I know that the measure of angle 3 from our given statement is already equal to 40 degrees. So we got that up here. So I'm going to plug that in. I know that that's equal to 40 degrees. So on my next slide here, I already got it. The measure of angle 1 is equal to 40 degrees because of that substitution property of equality. You can even argue transitive property of equality by cutting out the middleman with your measure of angle 3. So you can do it either way, but you're going to just prove that the measure of angle 1 is equal to 40 degrees. Okay, to wrap up what we're doing today for our last proof, you can see our last one, we've got some things with complementary angles. So we have given to us the measure of angle 1 is equal to 24 degrees. The measure of angle 3 is equal to 24 degrees. We have the angle 1 and angle 2 being complementary, and angle 3 and angle 4 being complementary. So to get you started, I wrote down all of our statements that are given to us. Some things that I'm already thinking about if I'm trying to prove that angle 2 is congruent to angle 4. I'm noticing that I have two sets of complementary angles. Since I have two sets of complementary angles, I'm almost thinking about that congruence complements theorem, but I don't see anything necessarily that is going to be equal to the same set necessarily. So maybe I might want to get there in between. So it's kind of like that's where I'm heading towards. So here's my step to get there. I'm going to say right now that the measure of angle 1 is equal to the measure of angle 3. And here's how I know that. They're both equal to 24 degrees. So since they're both equal to 24 degrees, I can either say I'm cutting out the middleman or that I'm substituting them in. I'm going to say that I'm going to be cutting out the middleman, or no, you know what? I'm going to go say substitution property because I'm going to be substituting in 24 in for the measure of angle 3. You can use either or. So I'm going to say substitution property of equality. Okay. Now my next move is I'm eventually trying to get towards congruence. So I'm going to take my statement of the measure of angle 1 and the measure of angle 3, and I am going to take those and I'm going to convert those into congruence. So for step 3, I'm going to say angle 1 is congruent to angle 3. And I'm going to say definition of congruence. All right, now, because I'm saying that I have a set of angles that are congruent to one another, I can then make this jump, and let's see if you guys can catch it. I can now jump and say that the angle 2 is congruent to angle 4. And here's how. All right, I'm going to take the statement right now of angle 1 and angle 4, or angle 1 and angle 3 being congruent to one another, and the other statements that I have above, And let's look at that and see if we can get to that statement with congruent complements. All right, so let's go back to that and let's read through the congruent complements. Okay, so if we have two angles that are complementary to the same angle or congruent angles, then they are congruent. So if the measure of angle 1 and the measure of angle 3 are complementary to the measurement of angle 2, then those would also be equal to one another. So let's see if we have that situation here. Okay, so I have angle 1 and angle 2, I have angle 3 and angle 4. All right, I know that these guys are equal to one another. So therefore, I can start saying things that, yeah, they're going to be complementary with 2 and 4 also. So that's how I can kind of make these jumps in between. So therefore, I can make the statement to go there, and I'm going to say that I'm going to go with the congruent complements theorem. So again, to be able to use that one, you have to be able to make that you have two angles that are equal to one another and they are going to be congruent to the same angle. So since we have that situation happening right now, then we can make that statement and be able to use the congruence complements theorem to get directly to that angle 2 is congruent to angle 4. So we're going to be practicing those a little bit more. A couple more to be adding to our list of reasons to be using in proof. Okay. So congruent complements theorem is one we can be using. Congruent supplements theorem is another one that we're going to be using. And of course, the right angle congruence theorem.